we're going to do solving differential equations with substitutions. And sometimes these are easier than other times, okay? So what we're going to do is we're just going to do lots of examples and where we have to make a substitution and solve a differential equation, okay? So rather than me explaining the method, we're just going to do examples and I'll show the method as we go through it, okay? So this first example we're going to do, x and y are both functions of t. What does that mean, that x and y are both functions of t? What does that statement mean? Why is it telling us that?
It's making y and x together.
Yeah. There's t is a parameter of this, we could say that, but it also means that I can differentiate x with respect to t. X depends on t, okay? And I can also differentiate y with respect to t, okay? So I'm given these two differential equations, and then I want to get to there. Now look at what we're trying to get to. Look at the green, and look what's in it. I've got a second differentiation of x with respect to t, d2x dt squared. So how am I going to get to that? What have I got above?
You want to get rid of all your y's, don't you?
I do, but look at what I've got and look at where I'm trying to get to.
You use the left one there.
The one on the left, what could I do? Look here, I've got down here,
Could you like differentiate it?
differentiate the top left one, yeah? With respect to
dt?
t, yeah, I want to differentiate with respect to t. So I'm going to start with this one on the left, and I'm going to differentiate it with respect to t, okay? And we'll see what we get. And basically, I'm going to look at what I'm trying to get down here, and see if I can make it out of what I've got up here, okay? Okay, so do you want to have a go at this then, Charlie? Do you want to try and differentiate this? Well, really, I just want to know what the 2x dt squared is, don't I?
Oh, yeah.
Okay, so what would I do with this?
Would it become d2x dt plus...
I think the first thing I'm going to do, Charlie, is just rearrange this thing we got up here, like that. Minus 2x. And then if I differentiate with respect to t, that's going to be that bit there.
Fine.
Okay? You good? Yeah? Yeah? Okay, do you want to have a go at it? How do I do it?
Is it... So if you differentiate it...
Yeah. With respect to t?
with respect to, do you get dx, d2x
Yeah.
over dt squared
Yes.
equals dx dt?
dy, I'm differentiating this with respect to t, so it's dy dt, right? With respect to t, yeah? Yeah. Minus 2 dx dt. Is that true? Yeah? I'm differentiating with respect to t. Yeah? Okay. Right. Have a look at it. What else can I do?
So dy dt is x.
dy dt is
Minus x.
minus x. Okay, cool. So I can say that d2x dt squared is equal to dy dt from the yellow one up there is minus x, yeah? Minus 2 dx dt. Now look at what we're trying to show. Just move it all onto the left and it will equal 0, yeah? Okay? So, it's plus 2, that's what we were trying to show, wasn't it? Pretty much, equals 0. So that one's done. Yeah? And it might, this is usually the first part of a question, so show that it can be written like that, and then the next part would be, now solve it. And you solve it using, it's a second order one, so it'd be like an auxiliary equation sort of thing. Okay? With respect to t. So let's just go quickly talk about what we've done. we got given these two things. We looked at what we were trying to show, and we saw that in the thing we were trying to show, the green, there was a second order differentiation. So I've looked at the yellow things and tried to look at how I could make the things in the green thing below, and then just sort of cobbled it together. Does that sort of make sense? Made some substitutions. Right, stop there. We'll do another one. Let you do it, and then we'll go through the video of that, and we'll maybe do 3 or 4 of them, and then we'll look at a past paper. Okay? Okay, so this second question. Use the substitution y equals zx. Now z is a function of x, and y is a function of x. Okay, so z is some expression with x's in. Okay, but it's just written as a z, and we want to reduce it to this. Now Charlie's absolutely right in what he's saying. We want to find what dy dx is. Okay, we'll find out what dy dx is. We'll find out what dy dx is, and we'll try and, once we find out what dy dx is, we'll write out this thing again, yeah, but we'll change what the dy dx is, and hopefully it's going to look like that thing over there. Does that make sense? Okay, so we've just got to differentiate it. We've got to do dy dx. Now, because z and x are both functions of x, I have to differentiate this. Be very careful. It's going to be the product rule for differentiation, which means it's going to be. What happens when I differentiate this? Can someone tell me? You got it, didn't you, bud? Okay, so if I want to differentiate this, it's going to be the differentiation of z with respect to x, dz dx, times x, plus the differentiation of x times z. So remember product rule, differentiation of one times the other, plus the differentiation of the other times the other. So this is just plus z, because the differentiation of x is just 1 with respect to x. Okay, you happy with that? So now I know what dy dx is. I'm going to sub it into there. Okay, so let's see what we get. We're going to get x squared times dy dx. Well, dy dx is just what we found out. Dz dx x plus z is equal to y times x plus y. Well, what's y? Are there any y's in this thing over here? No, so what's y? Zx. And hopefully, when I multiply all of this out, there's no y's in it now, I should get this thing on the right. Okay, so all I had to do was what Charlie said, differentiate y, dy dx, and then sub in, and just rearrange this thing. So let's just... Does it work, does it? So what I'm going to get on this side, x squared, x cubed, dz dx, plus zx squared. And on this side I'm going to get zx squared plus z squared x squared. Have I done that right? Yeah. Can I cancel a zx squared from both sides? I think so. So I've got x. And then finally, what can I do? How did we want it to look, first of all? Let's just go back up. Just divide by the x squared. Divide by x cubed. Yeah. dx. Divide by x cubed, so I'm going to get z squared over x. Brill. Okay? Happy? Similar sort of thing to the other one? Should we just solve this one as well? How do we solve this differential equation now? Separation of variables, so it's like a C4 one, isn't it? Separation of variables, so I bring the z down. If I want to solve it, should be that, isn't it? Have I done that right? Is that okay? What do I get if I integrate the left-hand side?
Left-hand side.
Yeah.
Minus.
Minus.
3. So minus 1.
Minus 1 over z. Yeah. And this side? Plus c, yeah? So times through by minus 1 3 minus ln x, and then how's that? That's the general solution.
Hang on, this is hence find y in terms of x. There's no y's.
Hence find y in terms of x. Yeah, well, can't we just change? Go back. Where was the question? Oh, it's not that one. Where is it? I can just sub in y over x for z, can't I?
Yeah. Yeah.
Okay. So I can, if I wanted to write it, what y in terms of x? And this is just z is y over x equals that. Yeah, and then just multiply. Okay. So yeah, I'm not worried about that. I'm just worried about this little techniquey bit. Okay. So I'll give you a chance to do another one. What we're going to do, we've got y equals vx. Again, v is a function of x. What's the first thing we're going to do? Someone tell me. What's the first thing we're going to do that? Anybody? There's a dy dx here, so it'd be good if we could find out what that was. So dy dx, what does it equal then, Vlad? You did it last time. Yeah, it's going to be the differentiation of v with respect to x.
Is that implicit differentiation?
Yeah. Cool. It's implicit, but it's a product as well.
Yeah, I get that, but it is implicit with
for what v is, yeah, you're just saying that. Yeah. So if it, for example, if it was v squared there, Charlie, v squared x, what would it differentiate to?
That be just 2v.
Yeah, very good. Okay, so you just differentiate implicitly, yeah. Because implicit differentiation is the same thing. You're saying y is a function of x, but you don't know what it is, so you differentiate that. Okay, plus v like that, yeah. Is that right? I've done that right, Vlad. So sub that in. So I've got, now, as I go through this, I've got x, y. I'm going to write y as vx, okay? So this is going to be vx squared. That's the xy. Then this, plus v, is equal to y squared. Well, what's y squared? What's y squared? Yeah. Do you agree with this, guys?
Yeah.
And then in this square root, I'm going to get x squared plus v squared x squared. Now, at this point here, I've done it. I've managed to turn it into equation in v and x, but it doesn't look very nice. Okay? Did you all get that? Okay. This thing here looks to me like it is solvable by separation of variables. Possibly. Okay? Now, what I'm going to do is we want to get... let me just multiply this out a little bit more over here. I've got vx squared dv dx plus v squared x cubed, sorry. No, it is squared.
Oh, the other one should be cubed. Yeah, it's vx.
Over here is cubed, yeah?
And then that's v.
And that's squared, yeah? Is equal to v squared x squared, so they're going to cancel, aren't they? Plus the root of x squared plus v squared x squared. So these two are going to cancel. We'll talk about, and so we're getting somewhere, right? Now it's this thing here. Who got to this point and couldn't quite work out how to get rid of the... Very good, Vlad. You impressed me today. Doesn't matter really, does it? Vlad's saying this, look. There's an x squared all the way through that square root, right? Okay. So, remember how square root... I'm going to do this in a few steps so you can see it, okay? Remember how square roots work. surds where I can multiply surds. So would you agree that that green thing there is the same as x squared rooted times by, I'm going to write it like this, I know it's a bit dumb. That's that, right? Okay, but what's x squared rooted? So that's how you get the x out of that root. Okay, so can someone, it is separation of variables, isn't it? Want all the v's on that side? All the x's on that side? So this is going to be v. Yeah, but I've got I mean, oh, that's square rooted, isn't it?
Yeah.
Is equal, dv, yeah, is equal to x, 1 over x squared? Dx. Okay, cool. Equals in the middle, yeah. Okay. The integration of the thing on the left. Here's what I think. The thing on the right, is that just 1 over x plus c? Is that the thing on the right? Yeah? Thing on the left, I'm just going to rewrite it as v times 1 plus v squared to the minus a half, yeah? Okay. Now, I'm just doing this by inspection. If I were to integrate this, the power would go up by 1, which makes it a half, right? Let's try and differentiate that. If I try and differentiate that, I'm going to get 1 half times 1 plus v squared.
Maybe divide by the new power base to it, so it'll be, so the halves will count. No, half.
No, hold on, I'm not worried about that. And then I times by the differentiation of the thing inside, which is 2v, yeah? Which is the same thing as what I had, wasn't it? So is the integration just 1 plus v squared to the power of a half? If I differentiate that, I get that, don't I? So it's alright. What about the v?
Yeah. If it was 1 plus v squared, then yeah, I don't like
No, I get it, I just don't know how you got to it. No, I don't.
Oh, I'm saying this, look. I'm saying this. Right? There's no trick or anything. I'm not trying to like.
I know you're acting nice. You just put plus 1 in and complete it, just do it.
What I'm saying is, I'm looking at this. I know the power. I'm trying to imagine what the answer is. So at first, it looks like a trig one. You know, with all those trig identities. It's not.
Yeah.
The power is going to go. I'm just thinking about it in my head. It's going to have some form like this. The power goes up by 1, right? I know it's going to look something like that. And all we do is, I'm just looking at that, and if I just try and differentiate it, the power goes to the front. I get exactly the same here. The power goes down by 1. And I multiply it by the differentiation of what's inside, which is
I got
2v.
that, but I just didn't know how you got to it. You say inspection, but not in a million years would I have seen.
Right, I am saying inspection. I'm saying it's got to have that form, and I just wrote that down and then said, oh, that is the answer, though, isn't it? Yeah.
It has to have that form. Sometimes you know forms.
Well, the power must have gone up by 1, right? So I just wrote it down, and it just happened to be the right thing. Yeah.
I know something like that.
Okay. So
I'd dig a hole and never found.
that's it. So so what did I say the answer was? 1 plus v squared to the power of minus to the power of a half, right? That's it. So c, and then I'm going to square it. So this is c minus 1 over x squared. I've changed the c to minus c there, but yeah. And then v squared equals minus 1, and then square root, yeah? Okay. So that's okay. Let's go through this one anyway. This is from June 2011, is it? Okay, so we've got this substitution, and and we want to turn it into a differential equation we can solve. So I'm guessing you do. What did we do? Did we rearrange? Do you rearrange this?
Yeah.
dy dx equals u plus 2x. Yeah. Do the second differentiation because you got the second differentiation up here, Charlie. Yeah. What's the second differentiation? Du dx plus 2. Yeah. And then I'm just going to sub dy dx, d2y dx squared, and into this thing up here, right? Okay. So I'm going to get x cubed plus 1 d2y dx squared, so I'm going to put that in as du dx plus 2 minus 3x squared dy dx, well that's dy dx, so this is u plus 2x, and that should equal 2 minus 4x cubed. I've got rid of all the y's, right? Okay. I'm going to multiply this out. So I get x cubed plus 1 du d. This should be is this a? That is just du dx, isn't it? There, it's not. Yeah. Du dx plus 2 x cubed plus 1, and then what have we got here? Minus 3 x squared u minus 6 x cubed, is that right? Okay, now if I start bringing all this stuff over, keep that on that side. What do I want on this? I want the u, right? Bring that 3x squared u over. And then I'm going to have minus, what am I going to have? Those bits are going to cancel, aren't they? I'm going to get 2 minus 4x cubed minus 2x cubed. Oh, hold on, what am I doing here? I've done something wrong, haven't I? Have I done something wrong? Does it all cancels, doesn't it?
Yeah.
Let's just skip. I have done it. It all cancels. So that just equals 3x. That's 3x squared u, yeah? Okay. So we get there to a differential equation that we can solve by separation of variables. Everyone managed to get to there? Okay. So by separation of variables, what I did was I brought the x's onto this side. So I think I did it like this: 1/3 1 over u du on that side should be equal to x squared over x cubed plus 1 on that side. Is that okay? And so I integrate this. On this side I'm going to get 1/3 ln u. On this side it's ln of the bottom, isn't it? Yeah, 1/3 ln of the bottom. Plus c. Yeah? Plus c. Yeah. So I can write plus c is like 1/3 ln or something.
Yeah.
Yeah. And then multiply it in. So this is 1/3 ln c of this, yeah? Because if I say c is a constant, let's call it log or something, then it's still a constant, and then I can put the logs together. They're added together, so they get multiplied there. now I can get rid of the logs. Yeah, I can get, there's third on both sides, so I can get rid of them there. Get rid of the logs as well, so this just goes to u equals c x cubed plus c. Is that right? Is everyone okay with that? But it wants it in terms of x and y. So at this point, you go back and you say, well, u was actually dy dx. Take 2x. And now what I do is I integrate this, right? So dy dx equals cx cubed plus 2x plus c, and I integrate this, so y equals cx to the 4 over 4 plus 2x squared over 2, so that's just x squared, plus cx plus another constant d. Is that right? Yeah, okay, that's it.